On July 1st, 2025, a telescope in the mountains of Chile, built for one specific job, spotting asteroids that might one day hit Earth, picked up something moving across the sky that didn't belong there. It wasn't an asteroid. It wasn't a comet born anywhere near our sun. Within days, astronomers around the world confirmed something that has only ever happened twice before in recorded history. An object had entered our solar system from somewhere else entirely, passed through, and was already on its way back out, never to return. They named it 3I Atlas. The 3I means it is only the third interstellar object humanity has ever confirmed. The Atlas comes from the telescope network that found it, and in the year since its discovery, this single object has been photographed by Hubble, analyzed by the James Webb Space Telescope, observed by spacecraft orbiting Mars, tracked by a probe on its way to Jupiter, and debated, genuinely, publicly, sometimes heatedly, by some of the most credentialed astronomers on the planet. Most of them will tell you it's almost certainly a comet, a very old, very large, very strange comet, but a comet nonetheless. A small number of them, including a Harvard astrophysicist with a track record of asking uncomfortable questions, aren't so sure, and have laid out a specific list of measurements that don't fit neatly into the just a comet explanation. By the time you finish this video, 3I Atlas will already be leaving our solar system for good, moving too fast for our sun's gravity to ever pull it back. We are not getting a second look. Whatever it is, whatever built it, or didn't, this is our only window to figure it out, and that window is already closing. To understand why this object caused such a stir, you have to understand just how rare it is for something like this to be caught at all. The ATLAS survey, short for Asteroid Terrestrial Impact Last Alert System, is a NASA-funded network of telescopes built with a fairly modest, unglamorous mission. Scan the sky every night, over and over, looking for anything on a collision course with Earth, and give humanity as much warning as possible if something is coming. It's not designed to hunt for visitors from other star systems. It just happens to look at the entire sky, patiently, night after night, which means every so often it catches something nobody was specifically looking for. That's exactly what happened at 05:15 UTC on July the 1st, 2025, when the Atlas station in Rio Hurtado, Chile, recorded a faint, fast-moving point of light. At the time it was discovered, the object was still roughly 5 astronomical units from the Sun, a little farther out than Jupiter, and it was already moving at around 221,000 kilometers per hour relative to the Sun. Within days, once enough observations came in to calculate its orbit properly, astronomers realized something remarkable. The shape of that orbit was so extreme, so sharply curved, that there was no way it had ever been gravitationally bound to our Sun. It hadn't formed here. It had come from somewhere else in the galaxy. It had been traveling through interstellar space for who knows how many millions of years, and briefly, almost accidentally, wandered into a solar system that happened to have a telescope pointed in exactly the right direction at exactly the right time. This had only happened twice before. The first interstellar object ever confirmed, ʻOumuamua, was spotted in 2017, and it was strange enough, a small, elongated object that tumbled through our solar system and vanished before scientists could gather much data on it at all. The second, comet Borisov, arrived in 2019 and behaved, for the most part, like a fairly ordinary comet, just one that had wandered in from another star system. 3I Atlas is the third confirmed visitor of its kind, and unlike the first two, this time, astronomers had months of advance notice, and nearly every major telescope humanity has ever built got a chance to look. Hubble examined it. On August 20th, 2025, using Hubble's imaging, NASA estimated the diameter of the object's icy core to be somewhere between roughly 440 meters and 6 kilometers, a wide range because a hazy cloud of gas and dust called a coma surrounds the actual nucleus, making its true size difficult to pin down precisely from a distance. Days later, on August 6th, the James Webb Space Telescope turned its infrared instruments toward it as well, with NASA publicly releasing the results on August 25th. Ground-based observatories in the Canary Islands and Hawaii confirmed the object was clearly active, meaning it was releasing gas and dust, just like a normal comet does when sunlight warms its icy surface. And this is where the story starts splitting into two very different interpretations. Let's walk through exactly where this object went, because the numbers involved are almost impossible to picture without laying them out step by step. 3I Atlas reached perihelion, its single closest approach to the Sun, on October 29, 2025, at a distance of about 36 astronomical units, or roughly 203 million kilometers. For context, that's just inside the orbit of Mars. At that exact moment, the comet was moving at its maximum speed relative to the Sun, approximately 246,000 kilometers per hour, or about 68 kilometers every single second. To put that in perspective, a commercial jet flies at roughly 900 kilometers per hour. This object was moving through space at more than 270 times that speed. Along the way, it passed remarkably close to several planets and spacecraft, almost like it was threading a needle through our solar system. In early October 2025, it passed near the group of Mars orbiters, NASA's Mars Reconnaissance Orbiter and MAVEN, Europe's ExoMars, Trace Gas Orbiter, and the UAE's HOPE Orbiter. And ExoMars actually managed to photograph the comet's fuzzy, glowing coma as it went by. NASA's Psyche spacecraft, on its own separate journey toward a metal-rich asteroid, also had a close approach around the same window. Then, on December 19, 2025, 3I Atlas made its closest pass by Earth. Though close is relative here, since it never came anywhere near dangerous distance, and conveniently, the date coincided with a new moon, giving ground telescopes an unusually dark, clear sky to observe it against. By March 16, 2026, the comet reached its closest approach to Jupiter, passing at a distance of about 6 million kilometers from the planet. A number astronomers noticed was almost identical to Jupiter's Hill radius, the theoretical boundary within which Jupiter's gravity dominates over the Sun's. Whether that's a genuinely meaningful coincidence or simply an interesting number depends entirely on who you ask, which we'll come back to shortly. By the time this video is being made, in mid-2026, 3I Atlas has already passed its closest approach to everything, the Sun, Earth, Mars, Jupiter, and is now speeding back outward, retracing its hyperbolic path away from our solar system for good. It entered on a trajectory so extreme that its orbital eccentricity was measured at roughly 6. 145? For comparison, a perfectly circular orbit has an eccentricity of 0, and even the most stretched out orbits of objects that actually belong to our solar system rarely exceed an eccentricity of 1. This object blew past that number by a factor of 6, which is exactly the kind of measurement that tells you, mathematically and unambiguously, that something did not form here. And it's not slowing down to stay. Once an object with this kind of trajectory swings past the Sun, gravity alone can never pull it back. 3I Atlas is now leaving, permanently headed back out into interstellar space, in the general direction it came from, a region of sky near the constellation Sagittarius, never to return to any part of the solar system again. While it was still inbound, in early November 2025, one more spacecraft got an unplanned front row seat. ESA's JUICE mission, short for Jupiter Icy Moons Explorer, already years into its own journey toward Jupiter's icy moons, happened to be well positioned to observe the comet from an angle no Earth-based telescope could match. According to Marco Fanucci, a near-Earth object dynamicist at ESA, scientists realized almost as soon as 3I Atlas was discovered that JUICE's position would let it observe the comet from a genuinely different geometry than anything possible from Earth. On November 4, 2025, JUICE passed within about 64 million kilometers of the comet, and its cameras and spectrometers gathered data that, in ESA's own words, would take months of preparation under normal circumstances. Data that is still being analyzed today. Here's where the story gets genuinely, legitimately strange. Not because of speculation, but because of specific published, peer-reviewed measurements that don't fully agree with each other. The mainstream scientific position held by the overwhelming majority of astronomers who have studied 3I Atlas is straightforward. This is a large, old comet, likely billions of years old, ejected from a distant star system long ago, and it behaves the way comets are supposed to behave. As it approached the Sun, it warmed up and began releasing gas. In fact, NASA's own Swift Observatory detected the chemical signature of hydroxyl, a byproduct of water being broken apart by sunlight, coming off the comet while it was still nearly 3 times farther from the Sun than Earth is, a distance where that kind of activity is considered surprising, but not impossible for an unusually large, ice-rich object. As it got closer to the Sun, its brightness increased faster than typical comets do, following a steeper brightening curve than Borisov did at similar distances. Again, unusual, but within the range, scientists can explain through differences in composition and size. Then there's the minority view, most prominently argued by Avi Loeb, a Harvard astrophysicist who previously made headlines with his controversial claims about ʻOumuamua back in 2017. Loeb and a small number of collaborators have published a specific list of measurements about 3I Atlas that, they argue, taken together, are statistically unusual enough to at least consider a non-natural explanation, even while acknowledging a natural comet remains the more likely answer. Among the anomalies Loeb has pointed to, the comet's orbital plane is tilted at an angle of about 135 degrees relative to the ecliptic, the flat plane in which most planets orbit the Sun, which technically makes its orbit retrograde, but also happens to keep it unusually close to that same plane. A geometric alignment, Loeb argues, is statistically less likely for a randomly arriving interstellar object than most orbital models would predict. He has also highlighted that the comet displayed what's called a sunward-facing jet, a plume of gas and dust pointing back toward the sun rather than away from it. The opposite direction a comet's tail typically points due to solar wind and radiation pressure. Standard cometary physics can explain sunward jets under certain conditions, but Loeb has argued this particular case doesn't fully match the geometry you'd expect from a simple optical illusion or ordinary jet activity. He's also noted that the nucleus appears to be many orders of magnitude more massive than either ʻOumuamua or Borisov, and that its flyby geometry brought it unusually close to Venus, Mars, and Jupiter, while keeping it largely unobservable from Earth around the time of its closest approach to the Sun, a combination of circumstances he has calculated to be statistically uncommon. To be clear about where the actual scientific consensus stands, NASA's own public-facing information describes 3I Atlas as a comet, plainly and directly, and attributes its small trajectory changes to ordinary outgassing. Gas escaping unevenly from its surface as it warms, a well-understood effect seen in comets throughout our own solar system. Multiple independent research teams, publishing in peer-reviewed journals, have modeled its brightening and behavior using standard cometary physics and found it broadly consistent, if unusual in scale. Loeb's interpretation remains a minority position within the astronomical community, openly framed by Loeb himself as a set of open questions worth investigating rather than a settled conclusion. A few of the other data points Loeb and collaborators have cited add to that list. Spectral analysis of the comet's coma reportedly showed an unusually high ratio of nickel to cyanogen gas, a ratio some researchers have flagged as far higher than what's typically seen in comets from our own solar system. Though the mainstream explanation is that this likely reflects an unusual mix of metallic compounds in the dust, a chemistry variation rather than evidence of anything artificial. Water ice content in the coma was also measured at roughly 4%, on the lower end for comets, which some have argued is more consistent with a rocky, metal-rich body than a typical icy comet, while others point out that low water fractions have been observed in other solar system comets too, and aren't unheard of. None of these individual data points is, by itself, considered proof of anything unusual. What makes 3I Atlas different from a typical scientists are baffled video is that this isn't invented drama for a thumbnail. It's an actual ongoing name disagreement between credentialed researchers, playing out in real, citable papers, about a real object, while that object was still physically inside instrument range. That almost never happens. Usually by the time the public hears about an interstellar visitor, it's already too faint and too far away to study further. This time, humanity got a front row seat to the entire argument as it happened in close to real time. It's also worth noting how this object was found in the first place, because the discovery circumstances themselves became part of the broader conversation. Days before the official July 1st discovery, the Vera C. Rubin Observatory in Chile, a next-generation survey telescope only just coming online for science validation testing, had unknowingly already captured 3I Atlas in its images on June 21st, 10 days before anyone recognized what it was. Once astronomers went back through the data, they found it hiding in plain sight, a faint moving dot nobody had flagged yet. It's a reminder of just how much of what passes through our solar system likely goes completely unnoticed, simply because no telescope happened to be looking at the right patch of sky at the right moment. So why does it matter whether 3I Atlas is just an ancient comet or something scientists haven't fully categorized yet? Because either answer teaches us something we currently don't know. If it's a natural comet, and the balance of evidence strongly suggests it is, then studying its composition gives astronomers a genuinely rare direct sample of material formed in a completely different star system, under different conditions, around a star that isn't our sun. We've studied plenty of comets that formed in our own solar system's outer reaches. We have almost no data on what ice and rock forming around another star actually looks like up close. Instruments on Hubble, Webb, and ESA's JUICE spacecraft, which made its own close pass of 3I Atlas on November 4th, 2025, just days after perihelion, captured spectroscopic data that scientists will be analyzing for years, comparing the chemistry of this object against comets that formed right here at home. And if even a small part of Loeb's list of anomalies turns out to reflect something genuinely unexplained rather than an unusual but natural coincidence, that would be one of the most significant scientific findings in modern history, which is exactly why serious researchers have been careful, publicly, to keep testing the natural explanation first, rather than jumping to conclusions. There's also a broader reason this matters beyond just one object. Every time humanity confirms an interstellar visitor, ʻOumuamua in 2017, Borisov in 2019, and now 3I Atlas, it reshapes our estimate of how many of these things are actually out there, constantly drifting through the galaxy, occasionally wandering into star systems like ours. 3 confirmed detections in less than a decade, largely thanks to newer, more sensitive survey telescopes coming online, suggests these objects may be far more common than anyone assumed before 2017. The Vera Rubin Observatory, only just beginning full operations, is expected to be sensitive enough to catch several more interstellar objects in the coming years, meaning 3I Atlas may not be the last unexpected visitor astronomers get to study, even if it is, for now, the largest and most closely observed one. Either way, the clock has essentially already run out. 3I Atlas is now outbound, moving away from the Sun at extreme speed, growing fainter every week as it retreats back into interstellar space. There won't be a fourth close pass. There won't be a chance to send a dedicated mission to catch up with it. Nothing humanity currently has could accelerate fast enough to intercept an object moving this quickly on this kind of trajectory. Whatever data has already been collected, from Hubble, from Webb, from JUICE, from ground observatories around the world during that narrow window between July 2025 and early 2026, is very likely the only data on this specific object that will ever exist. So here's where things stand right now in mid-2026. 3I Atlas has already made its closest approach to the Sun, to Earth, to Mars, and to Jupiter. All of that happened between October 2025 and March 2026. It is now on its way out, permanently, following a hyperbolic path that guarantees it will never return to any part of our solar system again, headed back out toward interstellar space in the direction of Sagittarius. The mainstream scientific answer is that this was an ancient, unusually large, unusually active comet from another star system, a genuinely rare and valuable natural sample that scientists will keep studying in archived data for years to come. The minority scientific position, laid out publicly and specifically by researchers willing to put their names on it, is that a handful of measurements about this object's orbit, its jet behavior, and its size don't fit as neatly into that explanation as we'd like, and deserve continued scrutiny even as the object itself becomes too faint to observe directly. Both explanations can't be fully confirmed anytime soon. There's no follow-up mission planned. There's no way to go back and look again. What we have is what was collected during that one irreplaceable window. And researchers around the world are still combing through that data right now, publishing new papers, refining their models, and, in at least a few cases, still disagreeing with each other about what it all means. We don't know yet which explanation is right. What we do know is that something did cross into our solar system from somewhere else entirely, moved through it faster than almost anything humanity has ever tracked, and is now gone, permanently, taking most of its secrets with it. If you want to see where this research goes next, whether new analysis of the archived Hubble, Webb, and JUICE data settles the debate, or whether it stays genuinely open, subscribe to the channel and turn on notifications, because the moment new peer-reviewed findings come out, we'll break them down here with the real data, not the invented version. One object, 26 months from discovery to departure. A debate that's still not settled. Thanks for watching.